Okay, hi guys. Welcome to math class. I am getting us all set up and ready for just a regular full day of math. So what I am going to do very quickly is stop my video over here. And I'm going to join quickly from my iPad so that I can have a little projector. So that you can see my notes. Because everything's going to be relatively normal today, okay? So I'm going to go ahead and stop my video now that you can see it. And okay, let's talk about what we were reviewing on Monday and Tuesday. And then yesterday, I know, was super crazy. So we weren't really able to do much just because of all of a sudden we're moving to remote learning and Miss Callahan had to go grab all of her stuff, and then some people needed to go grab their technology from the school. So all of that stuff happened, and right now we are just going to do a quick review on what we were learning on Monday and Tuesday. So we're going to take a look at our notes, okay, from input-output tables. And I'm going to go ahead and spotlight the video now, okay? So here's our notes from input-output tables, right? And we had listed some vocabulary on the left-hand side, and I'm just going to go ahead and zoom in just a little bit so that we can read it all together, okay? And your notes should say the same exact thing, okay? So make sure your notebook is out and you're following along because you will be taking notes today, okay? And it will be a part of your grade for today. So we added the vocabulary numerical expression, which we made a little model over here. So a numerical expression is kind of like a sentence that expresses with numbers, obviously, numerical expression, a value or something that we are looking for, okay? And then we put number 2, equations. Here we had an example, 7 plus 2, which we found was 9, is equal to 10 minus 1, which is also 9. So 9 equals 9, right? Just like 5 plus 3 equals 8, just like 6 plus 2 equals 8, 8 and 8 equal the same thing, okay? So these are equations. Then, friends, we have input-output tables, which is the soul of our instruction for today and for the next couple of days, okay? Because that crazy thing that happened yesterday put us all behind, and I still have some friends that probably aren't going to join us today, and they won't yet until Monday. So we have to be patient, and like I said, we're just going to review, okay? So here's our input-output table, right? And on the left-hand side where we have dogs, that is our input, right? On the right-hand side is our output. Now, we had to find a rule or pattern as far as how these two numbers were related, and we found that the rule or pattern was to take the input and multiply it by 2 to find the number of output, right? So in this case, we had 1 dog. For every 1 dog, they get 2 bones. So since we have 2 dogs, that means we would get 2 times 2, which equals 4. For 3 dogs, since every 1 dog gets 2, we do 3 times 2, which equals 6. And then 4 times 2, which equals 8, okay? So this is our rule. Input times 2 equals output. In this case, dogs times 2 equals bones, okay? Then the other day, friends, we started working on this thing, and I'm going to pull it up. Sorry, I know it's crazy. Viola is in the background again, making crazy noises. Okay, so let's look at Viola. Let's look at our math activity from, I believe it was Tuesday. Please stop. She thinks she sees or hears the cat. Viola. Okay, so this was our math activity from Tuesday before we left, okay, before we had our day off. And we were talking about our relationship between dogs and legs, right? So we built a table. Here, I'm going to stop sharing. Okay, So we put dogs, which was our input, okay? And we put 1, 2, 3, 4, 5, 6. So we were gonna find how many legs there were in total for 6 dogs. So we found that for every 1 dog, there were 4 legs. So we multiplied our input by 4 to find the output, which is the number of legs, right? So here in this case, friends, we kept continuing and we did our input times 4 to find our output, right? So we then decided this is our rule. Okay, so we built our table. Then we had to move to question number 2, which was to complete in a complete sentence, describe the numerical relationship between dogs and legs. Well, in our complete sentence, we wrote for number 2, for every 1 dog, right, there are 4 legs. Okay, super simple. So I had you guys highlight your input. So for every 1 dog, there are 4 legs, right? Which is our output. This 4 is our rule, right? Okay, now for number 3, I believe the question was, yep, it was, how many legs would you count if you went to the animal shelter and counted 33 dogs? Well, here what we had to do was copy our rule, dogs times 4 equals legs. And in this case, we were given the information that we have 33 dogs, right? So we filled in 33 for dogs. We knew our rule would follow times 4 equals legs. And then we had to do 33 times 4, right? To find the value, which was 132. Okay, so 132 legs in total for 33 dogs. Now for number 4, we had to find how many dogs there would be if we counted 48 legs. So we had to do a little bit of reverse in this one. So what we did is the same step. We copied our rule down, dogs times 4 equals legs. We don't know how many dogs, but we did know that there were 48 legs, and we copied down our rule. So then we had to do the opposite of multiplication here. So we did division. So we did 48 divided by 4 instead of times 4, right? Equals dogs. So we did 48 in our box. We divided it by 4. We didn't need to make another multiplication toolbox because we had just done it right here. We divided 48 by 4 and we found that there would be 12 dogs, okay? We did the exact same thing, friends, for our grasshoppers, right? So if we want to, we can look at this one and see just how that one is about the same, right? We'll just take a quick peek. And we know it was a really funny day, right? Because Bear kept saying, antennae, right? So we built a table, okay? And we put our grasshoppers, which was our input, okay, on the left-hand side. And then we put the number of antennae each grasshopper had on the right-hand side. And we had to find the numerical relationship to figure out what the rule was, right? So for every 1 grasshopper, there are 2 antennae, which is exactly what we wrote right here. For every 1 grasshopper, there are 2 antennae, right? So then they asked us, how many grasshoppers, okay, would there be if there were 124 antennae? So we copied down our rule, grasshoppers times 2 equals antennae. We didn't know how many grasshoppers there were, right? That's what we're looking for. We do know that there are 2 antennae per grasshopper, and we have 124 antennae. So we had to do the opposite of multiplication, which is division. So we dropped this down and switched it up. 124 divided by 2, right, equals grasshoppers. We put 1, 2, 4 in our box. We divided 124 by 2, okay? And we found that the answer was 62 grasshoppers. Then for number 8, they asked us, how many antennae would there be if there were 62 grasshoppers? Well, we just did that, right? So now we just had to rewrite it like that. So we had grasshoppers times 2 equals antennae, which is our rule, right? We know that there are 62 grasshoppers. That was given to us in number 8. Okay, I'll just show you really quick. So for number 8, boom, how many antennae do 62 grasshoppers have in all? Okay, and we know that it's multiplied by 2 to find the number of antennae, and magically 62 times 2 equals 124. We already knew that, so the answer was right here. Just like 124 divided by 2 equals 62, right? Okay, so now what we're gonna do is we're gonna flip. Okay, and I want you to put the date at the top right corner. And I'm gonna do that too. So today is, spooky, Friday the 13th. Fun fact, Miss Callahan was actually born on a Friday the 13th. Crazy. Okay, so let's look, okay? We're going to put 11 because it is the 11th month of the year, which is November, okay? The day is the 13th. So we'll put 13 and then the year is 2020. So we can just put a 20 right there, okay? Cool. So I'm just grabbing a different pen. I feel like this one's running out of ink. My bad. Okay, so now friends, we are going to now let's look at the number, okay? So this is the one from Tuesday, okay? Now we're gonna look at the one for today, okay? So let's look at the instructions right here first, okay? So it says important, read the directions on slide 2 before working on this assignment. That is critical because you should be watching this video right now and taking notes with me so that you don't have to do questions 1, 2, and 3 all by yourself, okay? Because I'm gonna model 1, 2, and 3 by yourself or with me. You guys are gonna copy down what I do. And then for 4, 5, and 6, you're gonna work independently. And those directions are right here, okay? So it says, watch the YouTube video lesson of Miss Callahan walking you through questions 1 through 3, okay? Which is exactly what you're doing, and right here will be the video that you're watching, right? And then when you finish, you're gonna upload the pictures of your notes that you're about to take with me to questions 1, 2, and 3. And if you need a reminder on how to do that for any reason, okay? There is a reminder right here, how to upload from your computer. Okay, insert image camera and how to upload a picture from your iPad. First, you will click the plus sign at the top. Then you will select image. After that, you will do from camera and then you will select that photo. It will say use photo and that is what you will do. Okay, cool. So we are going to take those notes and like I said, then you are going to complete questions 4 through 6 independently. So let's get started on this, okay? I'm going to zoom in so that you can read along with me. Okay, it says cockroaches. What? Cockroaches have flat oval-shaped bodies. The bodies of cockroaches are oily to the touch and may be cool or warm depending on the temperature of their environment. The head of a cockroach is small and is covered by a shield-like pronotum. Cockroaches have 6 long, spiny legs that allow them to run quickly across almost any surface. The specialized pads located at their tarsi are used for scaling surfaces and even allow for walking on walls and ceilings. A cockroach's mouth is directed down and backwards. Some species of cockroaches have wings that are flattened against their backs, although not all cockroaches use their wings for flight, okay? So what we are going to do is we are going to build a table that shows the relationship between cockroaches and legs. So cockroaches are going to be our input, legs are going to be our output. We are going to have to find the numerical relationship together, okay? So first and foremost, we need to figure out how many legs a cockroach has, okay? And I remember reading right here, it says cockroaches have 6 long spiny legs. So I know that for my input for the number 1 cockroach has 6 spiny legs. Okay, so I'm going to put that in my brain and I'm about to use it. But first and foremost, what I'm going to do is I'm going to go to my notebook and I'm going to put 1 in a circle, okay? And then I am going to switch back really quick and count how many rows I need to create. Okay, I know I need to create 1, 2, 3 columns, but I need to create 1, 2, 3, 4, 5, 6, 7 rows. So I'm going to count 2 down, okay? And then I'm going to count 1, 2, 3, 4, 5, 6, 7. Okay, so I should have 1, 2, 3, 4, 5, 6, 7 spaces. Okay, then I'm going to draw this all the way over to my margin over here. Same thing right here. Boom, 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 boom. Okay, and then I'm going to trace this faint little margin over here to close it up. Okay, and then I'm going to split it into thirds, which are 3 equal parts, right? So if I think about it, I need 2 lines. I'm going to split it here. And then I need to split this evenly. So I'm going to split it here as well. Okay, I did my best. It's not totally equal, but I tried to split it into thirds to the best of my ability. Okay, now I'm going to trace this line up here at the top. Okay, and I'm going to label it numerical relationship, just like I see right here, okay? Numerical relationship. So I'm going to label this middle column numerical relationship. Okay, cool. All right, so we already talked about what our input is going to be, right? And our input is going to be cockroaches, right? Because we're going to find the relationship between cockroaches and legs. Legs are going to be our output. So on the left-hand column, we're going to label it as cockroaches. And on the right-hand column, we're going to label it as legs. Okay? And what we already know, right, based off of the text, what we have read is that cockroaches have 6 spiny long legs, or long spiny legs, right? I highlighted it right here. Cockroaches have 6 long spiny legs. So we know from there that for every 1 cockroach, they have 6 legs, right? So now let's think about 2, 3, 4, 5, and 6 cockroaches. How are we going to find the amount of legs that they have, right? Over here on our output. Well, in order to find that, we're going to have to multiply our input times 6, right? So here our numerical relationship is 1, right, which is our input over here, times 6, okay, will give us our output, okay? So really quick, I want you to grab your light green crayon, just to bring back your thinking from Tuesday, okay? I know it's been a second. I'm gonna grab our light green, yellow green crayon, okay? And we are going to label or highlight our input, which is cockroaches. And we can go ahead and label this whole column because these are all inputs, right? So in this situation, here is our input, so we can highlight that. We had to multiply it by what the relationship is, okay, which is our rule. To find our output, okay, we're going to use our dark green, which is legs, which in this case, 1 times 6 equals 6, right? Okay, so now I want you to think, okay, now for 2 cockroaches, I'm going to do the same thing. I'm going to plug in my input 2, okay? And then I'm going to drop this rule down times 6. And 2 times 6, well, 2 times 6 is 12, right? Because I know my facts. So just like here, I had to input right? To find my output, I had to multiply times 6. Okay, so same thing. We're going to plug our input in, 3. We're going to apply our rule times 6. Okay, 3 times 6, right? And if I get a little bit stuck, I can just add 6 more to the legs, which is 12 plus 6 more is 13, 14, 15, 16, 17, 18. So I can put this down here, right? We'll just go ahead and label our input again, right? We applied our rule to the input to find our output. Same thing, 4. Apply our rule times 6. 4 times 6 equals 24. I know that one because that one rhymes. 6 times 4 equals 24. And if I flip it around, it doesn't matter because multiplication, you can do it in either order. And it's always going to equal the same thing. Same thing, 5 times 6. Okay, 5 times 6 equals 30. Because 24 plus 6 more, I know that 6 plus 4 equals 10, which would move me up into the next tens place, which is 30. And then 6 times 6 equals 36, because 30 plus 6 more is 6. Or I might just know my math facts, right? My multiplication facts. Okay, so go ahead and highlight your inputs, and then go ahead and highlight your outputs as well. Okay? Cool? Okay, now let's think about our rule, okay? So our rule down here is cockroaches right? Cockroaches, right here, the number of cockroaches times 6 equals legs. Whatever number we put right here, if we multiply it times 6, we will find the number of legs the cockroach has, okay? Or those cockroaches have in total. So we'll go ahead and label or highlight our input, which is cockroaches, times 6 equals our output, which is legs. Cool? All right, and don't forget about your light blue, okay? I'm using blue-green. Go ahead and highlight or label your numerical relationship, right? With the blue, okay? And circle your rule, okay? So just a friendly reminder that in our notes, okay, if we look back to Monday when we first started taking notes, this will help our brains. Input, light green, just like we did here. Output, dark green, just like we did here. And then our rule or pattern, we're going to call it rule, but we can just remember in our brains that pattern, right? Always works. We know that it is, let me reverse what I just said. What I meant to say was that our rule is the pattern that we see within our table, right? So we circled our rule, which is cockroaches, the amount of cockroaches times 6 equals legs, okay? So now, friends, we have taken care of question 1. This is the point in which when you're finished with this video, you're going to hop off of this and you are going to take a picture and add it right here, okay? And don't forget the directions are right here on how to add a picture. So I should see everyone's pictures from their notes. I'm not inserting mine today. Why? Because you guys are taking notes with me, okay? Cool. Now, for number 2, okay, it's asking us in our complete sentence to describe the relationship between cockroaches and legs. Well, this is a lot like what we were doing on Tuesday. Okay, so we have to think. Let's look. Think about this relationship right here. For every 1 cockroach, there are 6 legs, right? That is exactly what our answer is for our sentence. So what we're going to do is we're going to draw our line to separate question 1 and question 2. Okay. And we're going to write for every one cockroach, comma, just like we did over here, for every one grasshopper, okay? So for every one cockroach, right, there are, when we think about our rule, what did we have to do? We're going to multiply by 6. So for every one cockroach, there are 6 legs, which is our output, right? So we're going to label our output. Cool? All right, so now we have taken care of question number 2. We can draw our little line underneath it because we're done. Okay? And this is the point in which you would come back, and normally I upload the picture, but you're going to do this, okay? So you're going to go insert image, camera, or plus sign, image from camera, take a picture. You're going to put it in number 2 to show me that you've been following along during this time, okay? All right, and then for number 3, it says, how many legs would 93 cockroaches have? Okay, so let's check it out. We know that there are 93 cockroaches in this instance. We are not aware of how many legs there are, so we need to solve for it. So let's go for number 3. We're going to need to copy down our rule, right? Which is cockroaches times 6 equals legs, right? And like I said, if we look back, we see that we are given the information that there are 93 cockroaches. So here, we're going to plug in 93, because we know that that's the amount of cockroaches. Then we're going to copy the rest, times 6 equals legs. Okay? So now we can swing over to the right side, okay? Because we have this chunk of space that we can utilize, okay? So we have 93, which is our bigger number of the 2. So it needs to go on top. And we are going to multiply 93 by 6. So 6 is in the ones place. So I'm going to stack it underneath the ones place, put my multiplication symbol out, and then I'm going to start going. So the first step is I'm going to do my bottom ones by my top ones. Okay, I'm going to work from right to left. 6 times 3. Well, oh my gosh. 6 times 3. That one's tough. But if I think about the information that I have up here, 3 times 6 is the same thing, right? So 3 times 6 equals 18. So I can use this information to help me answer this question. So I'm going to put my 8 down here. I'm going to carry my 1, and I'm going to put plus sign in front of it so that I remember that I need to add that 1, not multiply, okay? So now I have 6 times 9. Oh my gosh, I do not know that one. 6 times 9. So what I'm going to do really quick, okay, is here's my little 9. I'm going to draw 1, 2, 3, 4, 5, 6, 7, 8, 9 dots, okay? And then here's my toolbox. And since I only need it for 9, so, oh, oops, I meant to make a 6, but it's okay. No, actually, it's not okay. We need to make this a 6. I'm so sorry. I'm grabbing my whiteout, okay? And I apologize, friend. If you could just go ahead and make that 9 into a 6 and erase 3 of those dots, because we only need 6 dots, right? So I'm going to turn that 9 into a 6, just like I did right there. Okay, and since I need to find 6 times 9, 6 times 9, I'm going to put my 9 down here. And then I'm going to think, what is the highest one I went to right here? Well, 6 times 6, so 1, 2, 3, 4, 5, 6, 7, 8, and then 9. I know 6. 6 times 6 is 36. So I'm going to fill out this one. I don't need to do 1, 2, 3, 4, or 5, okay, because I'm looking for 6 times 9, and that's not going to help me. But I do know that 6 times 6 is 36, okay? But I don't know what 6 times 7 is, so I'm going to count up from 36 in my head, and then I'm going to touch my dots, 37, 38, 39, 40, 41, 42, okay? And then 42 is in my head, 43, 44, 45, 46, 47, 48, okay? And then I just need to add 6 more to 48, so 48, 49, 50, 51, 52, 53, 54. Okay, so now I have the answer. 6 times 9 equals 54. I can't just write 54 because it is important that I add 1. So actually I need to write 55, right? So my grand total of legs is 558 legs. So down here, 93 times 6, which we just solved for, is 558. And I don't have to put equals because legs is my label. Legs, okay? And then I'm going to circle my answer, okay? And since I have solved for the amount of legs, okay, that 93 cockroaches have, I am going to go into my slide. I am going to upload an image of my work, which is, you guys are going to do that, not me today, okay? And don't forget, I've put the instructions over here, so I expect to see everyone's notes in here, okay? So here, friends, is where we come to an end of me guiding you through this, okay? And I'm gonna help you get set up for number 5, okay? So for number 5, I'm gonna zoom out just a little bit, okay? I wanted to show you something that I added, okay? Here's a little sound button. If you hover over it or you click it, it will play a voice of me reading it for you, just in case you are like wanting me to read to you, okay? Spider, an 8-legged predator. Okay, so I have gone ahead and recorded that for you, just in case you need my assistance with anything. That's totally fine. We have brand new vocabulary words that we've never even talked about, spider parts, all that stuff, okay? So if you click on this, I'll read it to you. Now, you're gonna learn about spiders, and then you are going to create a table. Now, let's look really quick at our page right here, okay? I want you to use this page, this previous page about grasshoppers, and this page about dogs to help you get through this without my help at all. Now listen, we've done 1, 2, 3 together. I think you can handle 1 by yourself. I actually know that you can handle 1 all by yourself, okay? So think about what we did here. The first thing we did was we built our table, okay? So when you finish reading about the spiders or listening, if that is your preference, I want you to count how many lines or rows do I need? How many columns do I need to split it into? Okay, so you're going to build your table, you're going to label your table, okay? And then you are going to complete that table and take a picture, okay? Just like you would right here. Then for number 6, same deal. I put in the little speaking of me, or the audio file of me reading it for you, okay? And you are going to tell me in a complete sentence the relationship between spiders and legs, and then you're going to tell me how many legs you would count. If you counted 46 spiders, okay? You guys can do that, but what I really want to quickly go over is that you can't do that on this page. So I want you to use this back page, okay? And this is what we're gonna do. One tiny thing, okay? I want you to put a 4 up at the top and circle it. You are responsible for creating your table. I need to see that you are able to do that without my help, okay? We've done it 3 times together. I know that you're capable, okay? Cool. So, friends, don't forget to use your lovely notes that we took together on Monday. Don't forget to use your lovely work with labels, okay? Don't forget to reference these materials to help guide you through this question about spiders, okay? This is you doing your own stuff. Once you are finished with 4, 5, and 6, you're gonna upload those pictures, okay? And show me your work. Now look, let's look at the last part of your math activity. So once you're done with this, you're going to go back to your math assignment, okay? And then you are going to use the attached link right here to go to Clever and complete your 20 minutes of iReady. Please don't forget, when you get into Clever, to click on my icon that says Miss Callahan's class. It's a little Bitmoji, or yeah, is it a Bitmoji? It's a Bitmoji of me with a little light bulb above my head, okay? So make sure that you are clicking that in order to get to the Clever that I would like you to work out of, okay? Cool, and just a friendly reminder that this is what it looks like. Boom, okay? There's a link to iReady and a link to MBRC. We're only doing our 20 minutes of iReady today, okay, friends? And then once we get into reading, you will do MBRC during that time. Is that understood? Cool. I will catch y'all at 9 o'clock now for reading. Bye.